Okay, today's lesson for calculus is a little bit of a review because it's your inverse functions and logarithms. Um, for the inverse trig functions, basically, they're in general, their radian angle x are not one-to-one because they're periodic, right? So if I had the entire sine curve, let me just extend this one a bit, it would just keep going on and on and on. So of course, if we try to do a horizontal line test of that, it would not be one-to-one. However, if we're willing to restrict their domains to intervals on which they are one-to-one, then we can be able to find out some more information about these. So the first thing we're going to spend some time on is talking about the domain restrictions that make trig functions one-to-one. So we're going to be limited to a region in which they're one-to-one, and we're going to talk about those. So basically, your domain in this case for sine of x is going to be negative pi halves to positive pi halves. For y equals cosine of x, the domain is going to be from 0 to pi. For tangent x, the domain is negative pi halves to pi halves, which you can see these two are similar except for what? This has a bracket and the tangent one has a parenthesis. Okay, cotangent as well is from 0 to pi. Tangent and cotangent are the ones that have open parentheses. Alright, secant is going to be 0 to pi over 2 and then pi over 2 to pi. And cosecant is going to be negative pi halves to 0 union 0 to pi halves. Now, I'll show a little bit more when we put these definitions, a little bit easier version to remember. So this is just basic ideas, a quick image and sketch of the inverse trig functions, their domain and ranges. So you could take a minute to look at that. I also want to make a note that y equals sine inverse. Make sure you know that this is not the reciprocal. That's sine inverse of x, which can also be represented as arc sine of x. So y equals cosine inverse of x is equivalently known as arc cosine of x, so on and so forth. Okay. Let's see. This is also just um, some more images. This is our normal y equals sine x curve from negative pi halves to pi halves. And this is with the sine inverse. This is if they're symmetric about the equation y equals x. So that you can see. Remember for the domain and range swap when you do an inverse right here. So you can look in comparison at your sine function, cosine compared to cosine inverse, tangent, tangent inverse, and then we have our other three trig functions down here. Cosecant x, this is the basic parent graph. Cosecant inverse x, then you have secant x, secant inverse x, cotangent x, and cotangent inverse x. So I gave you a handout for most of these. This is just to have a visual to go along with the definitions that we're going to be working with. And we're going to look at that next. Okay, but before we move on to the formal definitions, I want to show you this image and we'll come back to it in just a minute. These are the regions in which our domains are restricted to make the inverse one-to-one. And so if you want to think of it like for a visual, those of you that are visual learners, then the sine inverse is defined on the right portion of the unit circle. And its reciprocal is also the right side, except for this is cosecant x is 1 over the sine of x, so there's one location where it's undefined, which I put an x over it right there. Cosine is in the top half of the circle, okay, and its reciprocal function is also the top half of the unit circle from 0 to pi, except for where it would have division by 0. Tangents, the right side, now this one's going to be parentheses, negative pi halves to pi halves. And then cotangent is going to be the top half. So the ones that are in the top half are going to be these three, and the right half are going to be these. So maybe the visual will help some of you remember that. The next thing we're going to do is take a few minutes and write the definitions and reiterate this again. Okay, so if you want to pause this for a minute and write these down, we're just going to read over these definitions. So y equals the sine inverse of x is the number in the restricted region, negative pi halves to pi halves, which we see this as the right of our unit circle, for which the sine of y is equal to x. Okay, when we move on to cosine inverse, it's the number in the top of the unit circle region for which the cosine of y is equal to x. Okay, and when we start going over these examples, they'll make a little more sense to you, but for right now, it's just the definition. So y equals tan inverse is the number in which negative pi halves of pi halves. Remember, this is the top half, but we said the difference with tangent is that it's going to be a parenthesis instead of a bracket. And you can see why if you take a few minutes and look back at the graphs of those. And then let's move on to the next. Cosecant inverse, y equals cosecant inverse x is the number in negative pi halves, pi halves. This is the top, but y cannot equal 0. Okay, for which cosecant y is equal to x. And we're moving on to y equals secant inverse. It's the number in the top region of our circle, except for y cannot equal pi halves because it would be undefined there, for which secant of y is equal to x. And then x, our last one is x equals cotangent inverse. It's the number from 0 to pi. This is the top half of the unit circle. Keep in mind that cotangent and tangent have parentheses, while all the other ones have brackets. Okay, and one more thing we're going to look at before we move on to some examples is just our properties of inverses, and these are theorems in your textbook. So sine times the sine inverse of x is equal to x, and if you think back to inverses in algebra, that's the same thing. Okay, that's if it's in this region. And sine inverse times the sine of x is equal to x in this region. So on and so forth with each of these trig functions. So this is with the sine, cosine, and tangent function. So we can use these properties sometimes to solve and evaluate some of the problems we're going to be looking at. Okay, so our first example is use the reference angle to find the angles in the following example. So sine inverse of 1/2. Basically what we're doing here is we're going to say what is the angle in the region that's restricted here, which is, let's make a note of that over to the side. Our region is going to be the right side of the unit circle, which is from negative pi halves to pi halves. So I may want to make a note over here. So I'm looking for the angle in this region whose sine is 1/2. Okay, so let me pull up a unit circle real quick. Let's look in this region, so the right of the unit circle, and what radian angle in this region over here whose sine is 1/2, whose sine is 1/2. So what would be the answer to that? The y value is the sine, so sine is 1/2 right here, right? Positive 1/2. So I would say the answer to this is pi 6. Okay, let's look at another one. First of all, cosine inverse. Let me remind myself over here to the side, what region are we going to be working with? The top half of the unit circle, so that helps me visually. So my note is this. So I'm looking for the angle in this region whose cosine is going to be negative 1/2. Let's pull up a unit circle real quick. Whose cosine is negative 1/2 in this top region? Cosine is the x value. Good. Good job. So it's 2 pi thirds. So let's write that down. 2 pi thirds. Okay, our next one is going to be find the tan inverse, negative 1. So what's the angle? And let's do our reminder over here. So we're thinking to the right half, but recall tangent and cotangent are the ones that have parentheses. So cotangent, parenthesis, and then we're on the right half of our unit circle. Alright, so let's pull our unit circle up. What angle is in this region, okay, whose tangent is negative 1? Now, tangent is defined to be what? your sine over your cosine or your y value over your x value. So where is that going to be -1? Over here, good, we're in the right region, absolutely right. So it's going to be this one, 7 pi fourths. Okay, cotangent inverse 1. First of all, let's remind ourselves of our region. This is a parenthesis as well. It's the top half of the unit circle. So we're looking for the angle in that region whose cotangent is 1. Okay, so that's going to be here. Well, it looks like it's going to be what? Pi fourths? +1, so that's just going to be pi fourths. Okay, I'm going to let you attempt these last two, so if you'll jot these down and then try them on your own and check your answer. I do want to give you a heads up on number 6 though. So this, you have the option of rewriting this function as 1 over the sine function, which would be sine inverse of the square root of 3 over 2. So you may want to use your reciprocal there. Okay, so the first thing I did is define my region over here and my region over here, and then let me pull up a unit circle to answer these. So this is going to be, what did you get for this one in that region? Also, we could also look at this one. I didn't make that note. We could also do this as the cosine inverse of 1 over the square root of 2, which would be, yeah, so it may help to do the reciprocal. Not that you have to, but that one is just going to give us, what, pi fourths right there. And what did we get for number 6? Pi thirds, right? Okay. Okay, pause it, jot these down. These are some quick, just check yourself ones, so you can pause that, and then I'm just going to put the solutions. Okay, and there's a look at the answers. So we're going to stop here and then work some more examples in the next video.